Oh, hi, team. Welcome to a Marvelous Math Monday. Sorry I wasn't able to join you in person today. I do hope I'm feeling better soon, but I think I'm going to take tomorrow as well. I've caught my children's cold. They've all been home all last week, and they're still home with me today, and they may make appearances during these videos. So, thank you for your responses to the exit ticket. I was pleased to see that many of you chose to work in a group and didn't work independently. Working independently is fine, so long as that you're getting stuff done. But working in a group gives you a chance to draw on the experience of other people and all the things that they're doing. Most people struggled to get through even a quarter of the problems. Some people got towards a half and a little bit more than a half, and very few people got towards 90%. No one completed all the problems today. I'm going to see it's 4 o'clock right now. If I can do videos for all of the problems for you, look at this. Everyone, so there's at least 7 of you went through and just clicked yes to every single box. And that tells, I'm going to interpret that this way, that you really like these videos. You want to see video solutions to all the questions. So by popular demand, here I go. I'm going to organize these in groups of 11. So there's going to be 7 videos. Let's get started with the first 11 questions, everyone. I will try to outline for you the thinking behind each question, the way you want to understand them, so that if you find a question like this on EQAO, you'll be able to understand that, but also that you're armed with that knowledge going forward for grade 10 and your life. Okay, question number 1. So, considering this graph, we want to know, does this represent height versus weight? No, because if I have height here versus weight here, then you would think taller people would be heavier, and actually height versus weight would look something like this. As you increase your height, your weight would increase faster. Okay. Pay versus numbers of hours worked. No, that would be a line that would go like this. So no, it's not either of those things, right? Okay, why? If this was hours, T for time, and this was money, all right, then as we work more hours, we make more money. Okay, so you want to visualize those things, right, and say like, if it were those graphs, what would they look like? Gas remaining versus distance traveled. Okay, so if I have, this is now not money, but it's now liters of gas, and this is now kilometers traveled. All right. If I start out and I've traveled 0 kilometers, I'd probably have a lot of gas left. As I travel more kilometers, I'm going to use more gas until eventually I run out of gas. Aha! And then volume of water in a bucket versus mass. Again, that would be something like this. More water, heavier. Okay, so that would look like that, right? Why? If this is volume of water here, and this is mass, more volume, more mass. Okay, that's why we create that line. All right, so that one very definitely C. Okay, now let's keep going. Number 2, the graph below represents the relationship between earnings and time worked. So there's 4 different people, okay? And they've each, this is the amount of money they made, this is the amount of time they've worked. And just by looking at this, I can tell that this one here, M, has the steepest slope. Like it's steeper even than N. Okay, I'll show you. They worked 2 hours, M, and earned $40. So this is a $20 per hour at M. N, on the other hand, made $70 but worked for 4 hours. Okay, so they make how much money per hour? Sorry, like 1750 or something. My brain is not starting mental math. I just it was just refusing right now, saying no, I don't want to do that. Yeah, 1750. Okay, that was a guess, but the guess turned out to be true. So that N is 1750. These ones, P and Q, they're both lower slopes still. They're lower slopes. The slope is the amount of money they're making per hour. Okay, so which represents the highest rate of pay? M represents the highest rate of pay, has the best slope, has the best dollars per hour, $20 per hour. Okay, how do I find his dollars per hour? Well, He's earned $40 and he's worked 2 hours. So that must mean that it's 40 divided by 2 would give me the unit rate, which would be $20 an hour. Let's just keep going. Now, I really encourage you to follow along. I know you've struggled with these questions already. That's good. And now that you've done that, you can benefit from hearing me talk about them. You can also follow along, pause before my explanations, and see if you can get the questions right. Following graph shows a relationship between the mass and the cost of 4 different brands of strawberry jam. So, okay, these are 4 different brands. This is the cost in dollars. So brand C is the most expensive, but they're also giving you 400 grams. Okay. Which statement is true? Brand A has the lowest cost. Not true. Brand B is the lower cost. Brand B has the smallest mass. Not true. Brand A has a smaller mass. Brand C has the highest cost per gram. Not true. I can tell by slopes. Okay, I can tell visually by slopes. Look, if I draw a line to brand C, I even missed it. I went too high, but I was still below brand A. Okay, I'm going to erase that. So that shows me that brand C is less than brand A per gram. Brand D has the lowest cost per gram. Well, that must be true. Okay, and let's check it. All right. So the cost is $4, and we have 500 grams. So the cost per gram is going to be 4 divided by 500. And so that will be 4 divided by 500. Let's show you what that is. 4 divided by 500 equals 0.8 of a cent per gram. Okay, so not even 1 cent per gram. So let's compare brand B, for example. That costs $2.25 for 250 grams. So if I say $2.25 divided by 250 grams, well, that one costs, oh, look at that, 0.9 cents per gram. 0.9 is bigger than 0.8. So, oops, this statement is true. Brand D does have the lowest cost per gram, verified with calculator, but also we can verify with a ruler. If I do my very, very best to draw a line, oh, that wasn't bad. See how that line has the lowest slope of all of them? That shows me that it has the lowest unit rate. Okay, cool. All right. Total number. All right. Deshan has a candy making business, and this graph below shows the total number of candies his business has produced by the end of each day for the first 4 days. Okay, so total number of candies produced per day. If the trend continues, which of the following points represents a day with more candies produced than expected? All right, so here it just helps to, first of all, see what is expected here. And we would say this is our expectation going along like that. I think I've done a pretty darn good job of drawing a straight line, but you could really do a good job with a ruler. Now, 500. Okay, 5 days, 500 would be about exactly what we'd expect. That's a little low below there, right? Actually, that's 500 right there. All right. So we want a day with more candies produced than expected. 9, 8, 50. So here's 9 days. And then here is 850 would be there. Below expectation. 10, 1300. Well, that sounds pretty good. There it is. 10, 1300 looks to be a little bit over expectation. Let's just check the last one and make sure. No, that's going to be way below expectation. So that's it. Okay. How do I know it's way below expectation? Well, look at it. Here is 1400. 14 days, 1400 candies. So this here is obviously the one that is above expectation. So that's it. All right, for a new game, Xiao makes 2 numbered cubes, 1 green and and 1 red. She randomly assigns numbers. Excuse me a moment, throat's a little scratchy. She randomly assigns numbers on the 6 faces of each of the cubes, possibly repeating some numbers. She rolls a red and a green cubes together 9 times. She displays the number results in a graph. So this is the number rolled on the red cube. This is the number rolled on the green cube. Okay, I notice that the green cube can roll a 1, a 2, a 3, a 4, a 5, or a 6. The red cube can only roll 1s and 5s, it seems. Which of the following statements does the data in the graph most likely suggest about the cubes? Each cube has fewer than 6 distinct numbers on its faces, as some numbers are repeated on the cube's faces. No, it's not A, because the green cube can roll a 2, it can roll a 3, blah, blah, blah. It can roll all the numbers. So that's not true. Each cube has 6 distinct numbers. No, that's not necessarily true. The green cube has fewer than 6 distinct numbers on. No, the green cube has all 6. Okay, the green cube does not have fewer than 6 distinct numbers on its faces. The red cube has fewer than 6 distinct numbers on its faces, as some numbers are repeated on the cube's faces. That seems to be the most likely. D. Number rolled on the red cube. See, the red cube can only roll 1s and 5s. So probably the red cube has fewer than 6 distinct faces. Okay, now, here we've been asked about the 7 models of CD players that Sergio sells. Okay, the table shows the unit cost of each model and the number of CD players of that model sold in the past month. This is an old question, back when we used to use CD players. Which statement about the relationship between unit cost and the number of CD players sold is true? There's no relationship. As the unit cost increases, the number sold decreases, or blah, blah, blah. Okay, we've got different descriptions of different relationships we could have here. Let's take a look and see what relationships we have. So look at this. The number sold is increasing. The unit cost is increasing. Seems that more people like to buy the expensive ones than the cheap ones. Very interesting. So as the unit cost increases, the number sold increases. I don't know what much else to say about that. All right, number 7. Bruno leaves home and goes for a run along a straight path. He runs to the park, stops and rests, and returns home. Which graph best represents his run? So he leaves home, goes to the park, rests, and then comes home. Okay, and we've got all of these here. Okay, this one here. Okay, distance from home, time. Okay, why? Well, let's talk about this graph story. He starts at home. If he's home, what's his distance from home? 0. He's at home, so he's not far from home. So he's 0 meters from home. And then he leaves home and goes to the park. Here's the park here. That far from his home. Okay? He stays there for some amount of time. And then he returns home. If he has returned home, what's his new distance from home? Also 0. He's at home now. Okay. This graph story represents what he does. Okay. This one is he starts far away from home, travels towards home, rests a little while, and then travels towards home even faster. It's not that. Okay. The graph below shows a runner's distance from the starting point of a race over time. All right, question number 8. Okay. The runner ran at 2 different speeds and took 3 breaks. That's not true. Let's count the breaks. Breaks would be where his or her distance is not changing. And here are 2 places where their distance is not changing over time. If your distance is not changing, that means your speed is 0. That means you're standing still. If you're a runner, that means you're taking a break. There's 2 breaks, and then there's 1, 2, 3 different parts where they're moving. This one is fairly fast, this one is fairly slow, and this one is quite fast, and I can tell from the slopes. Okay, so they ran at 3 different speeds and took 2 breaks. It is that one. Okay. Last weekend, Jeremy traveled from his home to his friend's house. The graph below represents the relation between D, the distance from Jeremy's home, and T, the time spent traveling to his friend's house. Okay. Okay, so he traveled at a constant speed. He started from home, 0 distance from his home, and then traveled at a constant speed, fairly slow. Okay. This weekend, Jeremy travels to his friend's house but leaves from school. Jeremy's school is between his house and his friend's house. So his school, it's not all the way here. This is where his friend's house is. School is somewhere between his house and his friend's house. So let's say school is here. Okay. So last weekend, Jeremy left home, passed school, and arrived at his friend's house. This week, he's going to start from school and travel faster, something like that. Okay. Notice that I tried to draw a steeper slope than this, maybe even faster. Faster would be he arrives very quickly. All right. Less time would have elapsed, and he would have traveled the same distance there. Okay. So the new line will start at a higher point and be steeper. Tyler walks along the line, leading from a motion sensor. Okay. The graph below shows information about Tyler's walk. Okay, so this is distance from the motion sensor versus time. So we're measuring about 6 seconds worth of time here. And he starts 2 meters away from the motion sensor, ends up 4 meters away through there, and then walks back towards the motion sensor, finishing as close as 1 meter away from the motion sensor. This here is the time where he is approaching the motion sensor. Otherwise, he's either moving away or staying the same distance from the motion sensor. Okay, I kind of made a mess of that, so let's erase all those. So this is the section that we're interested in. This is where he's moving closer to the motion sensor. What is his speed in meters per second? Well, we just need the slope of that line. So he starts at, this is, I can look at it and I can tell you it's 2. Okay, how do I do that? A run is 1, rise is -2. So that's he's moving -2 meters away from the motion sensor. So that means 2 meters towards the motion sensor per second. There's 2 meters per second. Okay, but how would we do it with points? Okay, we could identify this point as oh wait, no, I am wrong. Oh, I made a mistake. It's a good thing I gave you a second explanation, or else that mistake would have lived on forever on YouTube. Okay, that's not 1 second. That is 1/2 of a second. This is more like and that's only 1 meter. Oh no, it's still 2. Oh, it's still correct. Okay, cool. All right, so here, why? Why is this the case? Okay, so I'll show you why. Let's label some points, everybody. This point here is in the X, that's 3.5 seconds. And in the Y, that's 4. Okay, 3.5 seconds and 4 meters away. This one is 5 seconds, 1 meter away. So it's 5 seconds, 1 meter away. Okay, so now let's do rise over run. M is his speed, is rise over run. And in this case, it's going to be, it rises -3, goes down -3 here. It's -3. I can also do 1 minus 4 will give me -3. And then it runs 1.5. Okay, so this is -3 over 1.5. Hey, Mr. Jennings, didn't you say that was -2? Yeah, I did. And you could check that with a calculator. But we don't say your speed is -2 meters a second. We say it's 2 meters a second towards the motion sensor. It could be 2 meters per second away from the motion sensor, and then it would just be going the other direction that way. All right. Okay, let's keep going. One more question, then I'll cut this video off and start a new one. There'll be 7 videos today. My goodness. I'm supposed to rest on sick days. Beth is working at a grocery store. That's a very wise use of her time. She's going to get a lot of transferable skills she can use in other employment in her life, and she's investing her time and converting her time to money. She earns $8 an hour for her first 20 hours of work in a week, and then $11 an hour for working beyond 20 hours in a week. All right, back in the day, everyone, minimum wage was not $15 an hour. The first time I made $15 an hour, oh my goodness. Anyway, um, all right. So is this one. Okay, why? Why is it this one? Because she earns a constant amount of money until suddenly her earnings change and grow better. Okay, but they're also a constant amount of money. That's why the slopes are constant and they create lines. This one is this constant earning, but this is like a good rate of earning and then a bad rate of earning. This is like they punish her for working too many hours. But that's not the way overtime works. You'll make more money per hour for your overtime. This one, well, if you can get this kind of work, then take it. This is you don't make much money for your first few hours, but the amount you're making is constantly increasing, which is pretty cool. And this is the amount you're making is constantly decreasing. Note that it would be hard to say how many dollars per hour do you make because the amount you're making is always changing. Whereas here, there's two different rates that you're making money at. That's why it creates two lines. Okay, and that's it for this video. So tune in next moment when I make the video for 12 to 22. Okay, bye for now, everyone. I hope your math practice is fruitful. Of course, hit me up by email with questions.